Okay, so that's Unity Hub. Well, I'll just walk through this real quick. So hopefully everybody was able to go through the um, application or the tutorial, and part of that was download Unity Hub. Unity Hub is kind of a centralized location that manages your various Unity editors. Current Unity editor looks like it's version 6 whatever. It's possible if you're on a Windows machine that your version might be slightly different. I think they're usually pretty good at releasing for Windows, Mac, and Linux all at the same time, but it's possible. But as long as you're in the same ballpark, like I said, I mean, I hadn't messed with it in a year. I did not detect significant changes in going through the tutorial with anything that's shifted, so I think you would probably be okay. Um, but in any case, um, uh, when you install the editor, so when I go to installs here, if there's something that is missing, so when you go to the little gear over here, you can say add modules. So for instance, I'm guessing if I didn't already have this installed, you could have installed Visual Studio Code. Historically, I used to use Visual Studio, which installed with it. I use Visual Studio Code a lot now because I work with so many different programming languages, and it seemed to work fine with it. There was a Unity plugin for Visual Studio Code. So whenever you're using Visual Studio Code and you are working with a Unity script the very first time, it probably had a little thing that popped up yelling at you saying, "Hey, we have a Unity plugin. Do you want to install it?" I click yes, and then all of a sudden it started working better for Unity stuff. But in any case, Visual Studio Code is what we call an IDE, Integrated Development Environment, fancy name for a text editor for programming. Does it try to auto correct stuff like Keynote does to me and gives you some command completion and all that jazz. Now, as you're going down here, right now, you probably don't have any of these libraries, extra libraries installed. So let's assume that you were creating a game and you wanted to output to iPhone or tvOS or Vision OS for Apple Vision Pro or native on Linux or native on Mac, whatever it is, you can include these build supports for those things so that once you're done building your Unity game, so no matter what thing you're building for, you're building it with Unity. Then you can export to iPhone or you could export to Mac or Windows or Linux or things like that. Just by adding this support and then going up, you have to configure a couple of things when you export to these different platforms. But that's kind of the beauty of using Unity for a lot of stuff. If you get this skill set under your belt, then you have to write all your applications as if they're 3D games, but you can write business applications that way too. Um, you could export to any of those platforms and it just works. You could also export to PlayStation. I think there's another thing to do it. You have to bring it in, but whatever. This tool you can export to really anything that you've played a video game on. All right. But right now we don't need any of that stuff since we're just running it inside of the editor. So I'll just close that. You would have created your first project. So when you create a new project, it comes in here and it gives you a bunch of templates for like starting points. I think for this tutorial, I had to use Universal 3D Core. I'm guessing high definition 3D must support larger textures or something like that. We're getting a little bit out of what I know about this, but making a 3D game, use 3D Core, it probably gives you everything you need to get the ball rolling. Not even on purpose, but it was just amazing. All right. So, in any case, once you created your application, it should open up in Unity like this, although it didn't have all this stuff in here. But when you go and run it, you should be able to drive the thing around and that kind of stuff. Um, I was not overly impressed with the AI, built-in AI stuff that's in this. Historically, it hasn't been great for this type of stuff. It's good if you want to have like, you know, things marching around your your game, just kind of acting like they know where they're going, pathing from one point to another. But I found that when you had the monster guy chasing your player, I could cut corners and it would kind of path through the wall a little bit. And so he was cheating, but not a big deal. At least you saw how easy it was to incorporate, call it basic AI into your applications. All right, so that's big picture with Unity. So now let's dive in and connect a couple of dots to what we talked about in class last time. So if you remember in class, I mentioned last time, I reminded us about this idea of design patterns. We had already learned about the singleton design pattern, and I introduced this new one called MVC, Model View Controller. And whether you were aware of it or not, you used Model View Controller as you were going through the Unity tutorial. So Model View Controller says it's a good idea to keep your user interface separate from your logic, separate from your data. So right off the bat, we see that we have Unity, which allows us to build our pretty user interface. And then we have these scripts that live behind the scenes. That's where we put our logic. And those two need to be able to talk to each other. All right. That's MVC, right? The mechanism by which Unity allows us to do that. All right. So let's walk through this project and kind of look at these scripts and kind of point out the highlights of what's actually happening rather than just typing in whatever the tutorial told you to do and not necessarily connecting. So hopefully this allows us to introduce some of the main primitive types of Unity as we're going through here. All right, so over here on the left, we have, let's just go to player. So player has some stuff that happens to player, and one of those things is a script called player controller that we wrote. Now, something that is built into Unity is something called player input. That's something that's relatively new. It existed last year, but a couple years ago, you would have had to write the ability to press keyboard keys to make your dude move around. You would have had to write that in a script, where now it kind of just does 95% of it for you. You just had to put a few things in. So anyways, if you look at our game objects here, so let me just take a simple game object. So here's a wall. Over here in Inspector, notice that every single game object at its most simple case is just a transform. So let's kind of get some of these things into the notes. Let's call this guy Unity primitives. So at the top level, we have a game object. This is anything we might be able to see in the scene. And actually, we probably should add scene to this. A scene is the current user interface we are working on. So if you move from one level of a game to another level of a game, that might be moving from the scene for level 1 to the scene for level 2, something like that. You'll notice that a lot of the things kind of use almost like the director of a movie type of verbiage. So we have the scene, you have actors, things like that. Okay, so a game object is anything we might want to see on the scene. You can think of this kind of like Java objects. This is the most simple thing that can exist in your game, is a game object. Game objects initially only have a transform. What's a transform? Well, we see up here, when I see my transform up here, transform has 3 elements associated with it. It has a position, it has a rotation, and has a scale. Where is it in 3D space? How is it rotated in 3D space? How big is it relative to its default size? So transform holds three pieces of information: position, rotation, scale. Each of those is stored inside of something called a vector 3. Vector 3 is a fancy name for a three-element array holding X, Y, and Z coordinates. Actually, probably behaves more like a dictionary, because you would say whatever the vector 3 is, dot X equals this, dot Y equals this, or even like a struct. Think of it like a struct. But holding three pieces of information, as soon as you start getting in these mathy sounding names, it can get intimidating, but a vector 3 just holds three pieces of information. There's also something called a vector 2 if you were doing 2D game development, that guess what? Holds two pieces of information, X and Y. One thing that's nice about using a game engine like Unity is, especially as we start getting into this a little bit more, you already, as part of the uh, tutorial, you worked with something called a rigid body. And a rigid body says, I'm going to make this game object be solid as if it exists. And then you have a little check button that says, do I want this thing to have gravity, be a force that impacts it? If yes, well, then if you don't have a way for it to collide with something else, it will just fall out of the sky and go right through the ground and things like that. So Unity's handling all that for us. As the programmers, our skill set is just knowing, well, what do we click? What do we turn on? What do we do? So most of our actual unique logic we're writing inside of our scripts behind the scenes. All right, so we have vector 3, and we can say every game object. Actually, let's put that under game object. Can hold 0 or more additional components when there's a zillion components. All right. So when I clicked on walls, you see there's not a whole lot going on with wall, but when I click on ground, notice the ground came with a bunch of stuff. Okay, so the ground came with, anytime you see the word renderer, that means make it appear. So if I wanted that thing to just disappear, I can click that, and you notice that now you have this new thing there. Kind of shows that our ground is gone, but the baked nav mesh is still there, so that's why we still see the blue. We also have something called a collider. So there's box colliders that come with the there's sphere colliders that come with spheres. There's box colliders that come with cubes, so on and so forth. This is a mesh collider. A collider is something that will interact with other colliders to allow us to either programmatically deal with two things bumping into each other, which you did in the tutorial, or just have Unity do whatever happens when two things of this mass bump into each other. How hard do they bump off of each other? That type of thing. All right. Unity will do all that work for you. All right. So going into player, we see that player is just a ball. So we made it a sphere, came with his own sphere collider. We added a rigid body to make this player being able to bump into other things. We added the player input component, which allows us to respond to the key presses. And then we wrote this player controller script. So let's go and look at this dude. So here's my player controller. Big enough, we can read it. All right, so up top, just like in Java, this is all C# code. So instead of import, we have something called using in C#, which allows us to bring in other libraries. Just like for like random, we imported java.util. In this case, since we're dealing with Unity stuff, we are using Unity Engine, which has a whole bunch of libraries built into it. We're using the Unity Engine input system. We needed to add that to give support for that input. If I scroll down here, here is our on move that was added based on our movement value from our input. This is how the player motion thing built in already works. We'll come back to that here in a minute. We also had to add a library called TM Pro for Text Mesh Pro. This is just where the thing that allows you to put some text on the screen comes from. This is the support for that. All right, the top level, we have a class just like we do in Java. Class here is called player controller. Notice it matches the name of the file, player controller CS, just like in Java. This little colon here, that's the replacement for Java's word extends. So in this case, we have a player controller, which inherits from something called a mono behavior. Let's go and add mono behavior to our notes. This is a core piece of Unity. So we have this thing called a mono behavior. A mono behavior is associated with any game object that we want to have automatic control over each, call it each frame, as well as have an opportunity to add logic when the game object first enters the scene. Could probably go a little deeper than that with it, but effectively, when something is a mono behavior, it gives us initially two functions. It gives us this function called start. What happens in here is anything you put in start happens exactly one time when the game object first enters the scene, before anything else happens related to this game object. So we can say comes with a start function, is called one time when the game object first enters the scene. Good. Auto behavior is spelled exactly like I copied it. Yep. All right, so comes with a start function. And it also comes with an update. We updated this, if you remember in the tutorial, to something called fixed update. So let me just talk about both of those. Comes with an update function, which is called every single frame while your game is running. Optionally, can have a fixed update function. What happened? Fixed update function that attempts to limit your game to 60 frames per second. The idea would be is if you're using the update function and you have a more powerful graphics card than somebody else who's running your game, the update function will get called more often because your more powerful graphics card will be able to show more frames per second than somebody else's. If you maybe that is what you want, depending on the type of application that you're writing. But if you're creating a video game and having something happen a fixed amount of 60 frames per second, 60 times every second, often is plenty. Um, then you might use fixed update instead to just limit it to 60 frames per second and probably allowing a majority of computers to be able to hit that. If you have a really, really, really old machine and you're writing a pretty complex game with a lot of stuff going on, it's possible you won't be able to hit the 60 frames per second, but that's what fixed update is for. Okay, but from a mono behavior perspective, we really get two abilities. We have the ability to do something one time when the game object first comes into the scene, and then we have the ability to potentially do stuff every frame or every so many number of frames. So this is the thing when we have active objects in our scene. Not everything has to be an active object, and we'll see that. So for instance, when we bring our dungeon in here and we start creating classes for our dungeons, they will probably not be mono behaviors because we're using them to store information, store the data associated with what we're seeing on the screen behind the scenes. It's not something that is going to get updated every frame or something like that. And we'll see that by example when we get into it. All right. So in this particular case, we see inside of start, we're doing some initial setup stuff. We scroll up to the top here. This should look fairly familiar. We have a whole bunch of private fields, right? We have this one thing called a rigid body. We mentioned that a rigid body basically makes something physically there. It has weight, it has, it can bump into stuff, things like that, compatible with gravity. We also have a couple of floats. These are just decimal point numbers. We have an int called count. All right, forget about these couple that are public for a second. We're going to swing back and talk about that in the context of MVC in a second. So we have several different fields. Inside of start, what are we doing? We are giving our rigid body a value. Now, I typically would use the this keyword when I'm talking about this stuff. So I would say this dot rigid body because I am talking about the RB variable associated with this instance of player controller. But since we are in a non-static context here, you don't have to use this dot. I typically do to avoid spelling errors. I copied and pasted this, so I didn't have to worry about that. Similarly, with get component, this is this dot get component. And we're saying, give me the rigid body associated with this object. That is the object that has this player controller attached to it. So if we go back to Unity here, we see that it is the player object, player game object, that has this player controller script associated with it. So when we say this dot get component rigid body, it's going to get us this guy right here, this component. All right, so we're seeing it in the inspector here, but programmatically, this now gives us access in our logic to work with that rigid body directly. We're also initializing our count. I would probably say this dot count. This has a when text object, so anything that's a mono behavior must be getting this thing. So this dot when text object comes from mono behavior. And then we have a function that we're calling called set count text, which we wrote here. What does this guy do? It basically writes the stuff that we ultimately want to put on the screen, just creates a string in a certain format. And this should even look relatively similar to what you've done before. This is a string. We're concatenating onto that string. The count, we see here that in C#, integers do have the built-in ability to convert themselves to strings. So if you remember from Java, we had noticed in the documentation that there's a whole bunch of classes dealing with all of our different primitive types. There was like an integer class, a character class, things like that. In C sharp, those things do still exist, but what they've done is they've kind of merged them together so that if we have a primitive type, we can make calls on it to get to functions that might be beneficial for us. One thing I mentioned when we were talking about first introducing Java and comparing it to C sharp, I said it was C sharp's kind of the result of a lawsuit between Sun Microsystems and Microsoft. So Sun Microsystems originally made Java. Microsoft lost the lawsuit. They had to stop using Java syntax in their stuff. So they created their own brand new programming language called C sharp that looked almost identical to Java, but we're seeing here that there are some things that they improved upon. So C sharp is not just a grab and go. You know, there are things that C sharp does better than Java or has improved upon with Java. And then Java, through newer versions, has added stuff back in. So this would be one of those things where, hey, I need a string version of this int. So I'm just going to ask it to convert itself to a string to concatenate those things together. This was for picking up those objects. So I only have 8 of those pickup things in my game. So if you've picked up more than 8 or equal to 8, go ahead and kill off the enemy and show the score thing. You know, you won. You won your. We had a win text object for what should display to the screen. That's this guy right here. Okay, let's see. So, any case, among other things, what did we do in start? We initialized our rigid body, and we extracted the rigid body from our player object, the game object that owns this script, so that presumably later on in the program, we can do things related to the solidness of our game object, the rigid body, you know, things like force it in a certain direction, that kind of stuff. We also initialized our count. So if we go all the way down here in the bottom and we go to, well, let's look at fixed update first. So this guy, this occurs 60 times per second, trying to emulate 60 frames per second. It doesn't matter if you use fixed update or update for our purposes. Realistically speaking, most of the things we're writing, since they're going to be low resolution, probably would happen more than 60 times in a second. So if you want to save a little computational power, switch it to fixed update to limit it to happen no more than 60 times a second. But what are we doing here? Well, we're creating a vector 3. We already learned what a vector 3 is. Tiny array that holds 3 pieces of information. And it's going to be a new vector 3 based on whatever this value is, movement x, nothing on y, and this is z. And I know the variables are misleading, okay, but it is x, y, and z in our vector 3, and it'll make sense here in a second. We're basically saying when my player moves, I don't want it to elevate into the sky. That is the y-axis. So we're treating the z-axis as the y. Z is depth into the screen. So x is this way, z is into the screen. Where are these values getting set? Movement x and movement y. They're getting set inside of this onMove function. This guy is called automatically by the player input component. All right, so we didn't have to worry about this. We just had to know that if I'm going to use the built-in player input, I have to put this function in here because this is the guy that player movement thing's going to call whenever we start messing with the keys to move our player. And every single time it calls it, it's going to pass in an input value based on the movement we did when we hit that key. So what are we doing? We're getting a vector 2, which I mentioned is X and Y, just two values, right? So we're going to get that vector 2 from the movement value. So this movement value here is a input value. That's the kind of object it is. And if we go and look up, I look up unity, called input value. So here's our class input value, similar to what we ran into in Java. We can scroll down. We can see the things that live in there. Not a whole lot going on. People use with game object messages. We have an is pressed. We have a get, which gets the value as an object. Right here, we're using get, and we're saying, get me the vector2 version of this input value. We've even seen this syntax before. What's that syntax called? We learned about it when what I have highlighted there. We learned about it when we talked about array lists. Takers?
Isn't it like generics?
Generics, yep. Not that important, just knowing that this is what's connected. So hopefully what you're seeing here is we're bumping into a whole bunch of stuff that we've already seen before, even though it's using words that we maybe haven't seen before because we didn't use those in Java, but they seem to be commonplace in Unity. So what this is saying, that it's saying get the vector2 associated with this input value. Because if I don't specify that I want the vector2, what it's going to give me is a generic object in C#. And notice that object's lowercase o instead of uppercase o. Go ahead.
So there.
Well, generics is kind of like precasting, because you could use just the get function. I could take this part out, and then this guy would come out as a generic object. I can then say, I want this guy to be a vector2. Make sense? So now it's possible, I don't know for sure with input value, but Unity does a couple of kind of things I would call syntactic sugar. And we saw that, let me put this back so I don't forget. We saw that up here with our rigid body inside of start, when we said we want this game object to give me its component. Which component? Its rigid body. So get component is operating off of like this collection of components that are hanging off this game object. And it's using what we put inside of the generic syntax to determine which of those things you wanted. So it goes in and gets you the correct thing, where if I don't put rigid body in there, it's not going to be happy. So it's kind of stealing the functionality of generics to get you the thing you wanted. Otherwise, maybe it could have had you just put it as a string in here as an alternative when they built it, but that's not how they built it. But to your original question, it effectively makes it so you don't have to typecast. I didn't have to turn it into a vector2 because I asked for a vector2, and regardless of how it got it, whether it extracted it magically from a collection of other things or that's just what it was and it came out as an object, it kept me from having to cast it to a vector2. I just got it as the thing I wanted. And we saw this exists in Java, this idea of generics. And that's actually kind of a big deal. That's something you'll historically, when we would teach the data structures course, the whatever CSC 3000 or whatever, it used to be 300, CSC 300. the course that comes after this one in coding. When we used to teach it using C++, to really get you into pointers quite a bit, we would write generic linked lists where things would come out as objects. Well, back then, C++ did not support things like generics. They've added it since to catch up with Java and C Sharp. But so basically, across our entire program, we were typecasting all over the place to get it to the actual object we were storing. So it's just a convenience thing. Let's see. So in any case, this function gets called automatically by that player movement component we added to it. Every single time we hit a key and we try to move, it gives us an input value. We grab the X and Y from that input value, and then we set this field, this global variable, movement X, movement Y, which we defined up here. These are private fields, just like we've defined in Java up to this point. We just set those two floating point values equal to whatever the current X and Y is. All right. So if you consider this, when we're pressing the keys on the keyboard, and that component that we added, the player movement component, it's going to call this function, and all this function does is it sets a couple of variables up top. That's it. No movement has actually occurred. It's just setting locations, X and Y's. When does the movement actually occur? 60 times a second. It occurs 60 times a second right here, where we go ahead and we build a vector 3, passing it movement X, which got set up above for our X, movement Y for our Z, since our guy is moving depth-wise into the scene, and we just made sure he didn't take off into the sky. So this vector 3 is just storing 3 pieces of information, and then what do? We take our rigid body and we shove it. We add force to it. Given that movement vector 3, so you think of vector 3 as like a XYZ coordinate, I'm gonna walk up, I'm gonna shove you in a certain direction, a vector. In this case, I'm shoving you over and forward, just not up, times the speed at which I want it to move. How hard am I shoving you? So these two values multiplied together, this is doing matrix math behind the scenes for us. If you've had linear algebra in high school or something like that, you would have done this by hand. You don't have to do that now. You just say, look, Unity, I want to shove this hard in this direction. So multiply those two together and add that force. Go. That's what a physics engine does, game engine. All right. And this will happen 60 times a second. So you imagine as you're pressing the keys and things like that, it's constantly shoving it 60 times a second, which makes the thing move. Okay. Questions about any of that before I keep cooking? These are all things you did through the tutorial, but kind of giving some color commentary into what's actually going on. All right. So now let's look at these couple of public things. So I mentioned last class, we've talked about MVC, and the idea is MVC, model view controller, is the idea that we keep our logic in one place right here. We keep our user interface in another place out here. And there's some mechanism for allowing them to talk to each other. When we made speed public here, that is the mechanism by which Unity implements MVC. It says if you have a field that you want to be changeable inside of the editor when you're working on your user interface, make it public. And if you do that, notice down here for our player script, we have speed right here. It became available to us. All right. Just putting the word public in front of it. That's how Unity handles MVC. All right. Similarly, I had public text mesh pro GUI, which was our count text. And I also had a public game object, which was our win text object. So these two things are physical things that are in our on our screen, as opposed to speed being a float. So when you look down here, you see that for speed, I can just type in any sort of number I want. That's how I'm inputting it. But if I need to give it my count text, which is this guy right here, I had to drag it over to set that value. And by doing that, what I did is now I gave my code programmatic access to this guy right here so I can change it. I can put text on there, things like that. I can make it disappear. I can make it appear, things like that. I did the same thing with my win text. Right? So my player controller script knows about the speed, knows about the count text, knows about the win text because it made those public inside the script, allowing me to hook them up to connect them to the interface builder side of things. Does that make sense? So really a pretty simple implementation of MVC. If you want it to be available out there, put the word public in front of it. Done. And you see here that by default, we had the speed at 0. So you could always have a default value for speed and then not even make a change to it out in, so if I set the default value to 30, then out there, the default before I make any changes would be 30. And if I'm happy with that, you don't have to put in a value in there. But for things that are objects where you're saying, hey, I want to get the actual count text, the text mesh pro thing, there isn't a such thing as giving that a default value because you're asking your scene to give you access to that guy. So that's when you have to drag it in. Okay, questions about that? All right, so then looking at the rest of the logic here, when the game started, we set the count text. The count text, what does it do? It sets it to whatever the current count is, which by default was 0 when we first started. I hadn't collected any pickups yet. If I've collected all 8 of my pickups, then it gets rid of the enemy and puts the win text up that, hey, I won the game, yada, yada, yada. Otherwise, set count text is just going to be showing you what your current count is. That's always up there, I think it's the upper left-hand corner of the screen. Okay, so let's go back out here and let's look at our pickups. So one thing you saw is they leverage this idea of an empty game object pretty often for kind of organizing your code so that you didn't have a zillion game objects just hanging out over here. An empty game object, so right now I have pickup parent, which was an empty game object. Notice that he still has a transform, right? He has a position, a rotation, and a scale, but he has nothing visual about him. We don't see any extra components on here that make him appear on the scene. So he technically is a game object. He's chilling invisibly somewhere in our scene at location 000. But we can't see him. We are not interacting with him. He has no collider or anything like that. He's just there. So we can leverage him. So for all intents and purposes, we're really just using him as a folder to store our other game objects so that we can hide him inside there. All right, so here's all of our pickups. So we designed our pickup once. So pickups look like these little yellow box things here. So a pickup, notice he has a whole bunch he started off as a cube, right? And so he would have been at 000, whatever. We moved him around. We set his rotation to be 45 degrees. So he's no longer sitting as a flat cube. He's now sitting as a, he's now sitting, I don't know, like in a cool posture, whatever. All right. He has a mesh renderer so we can see him. We turn that off. Now we can't see them. Turn it back on. Now we can see them. So whenever you see the word renderer, it means, can you see me? All right. And you can disable components just by hitting the check boxes for ones that are disableable. Let's assume that's probably a word. This guy has a box collider, which means he has kind of this like aura about him that other things that have colliders can bump into. And we can become aware that they were bumped into. Now, notice that for this box collider, I've set it as a trigger. All right. Anybody remember from doing the tutorial what the difference is between having it be a trigger versus not having it be a trigger? Good.
Able to tell the player has hit it. Able to hit it, whereas it is just.
All right. So trigger means that when a collision is detected, the programmer gets to handle it in code however they want. There is no automatic, just a gravity / mass stuff that occurs. So you're not going to actually see them bump into each other. This is something that we get to totally handle. If you have it as not a trigger, they physically hit each other with the gravity / mass stuff. And we can optionally do some logic in code. So this allows you to have things that you make your game objects, you give them mass, you turn on gravity, whatever it is, and you're just saying, look, I'm not writing any code for this. Just if these two things smash into each other, make them look like they smashed into each other in real life. Game engine does all of it for you. All right. But you can then optionally do something else. In this case, we didn't want to have our pickup fly across the room or something like that. We just wanted to kind of programmatically detect that our player and our pickup touched, and then we made the pickup disappear and we added one to our count. How did we handle that? We handled it, let's see, on our inside of player controller. You could have also done this inside of your pickup. So you can decide, in fact, you can do it in both. The pickup can become aware when a trigger was entered. The player can become aware when a trigger was entered. But we put this in the player controller. So this is a built-in function on trigger enter. I'll actually put this in the notes here. Say done through on trigger enter function. Whatever. All right. So on trigger enter takes in as a parameter a collider. This all gets done for us, okay, behind the scenes. So it's going to send in something that is a collider. What does it mean to be a collider? It means you're a game object that has a collider component associated with it. So what they're going to send in is the component from the game object that hit this thing that is the colliderness of it. Then we worked with tags. Tags are a way to kind of label certain things in our game. For instance, we have, in my case, I have 8 pickups, so we're out of time. I have 8 pickups, and we need to be able to detect that it was a pickup and kill it. All right, so I'm going to put a little error in here for right now. So we'll pick up where we left off next time, finish walking through this, but hopefully you're seeing there's a lot of overlap. All right, so no homework for next class, but keep looking at this. If you were having problems getting Unity installed or whatever, try to get it going by next class because we're going to be diving into this pretty quickly. All right, I'll see everybody on Wednesday.